Hi everyone, statics of engineering. In this problem, we have the screw eye, which is shown in the figure subjected to two forces of F1 and F2. F1 is 150 newtons and F2 is 100 newton. We want to determine the magnitude and direction of the resultant force based off the forces provided in this figure. So to approach such problem, we need to first just jump to two important mm, law in math like cosine law and sine law. The cosine law it just says if we have a triangle like what you can see here with the dimensions of A, B, C and the opposite angle of, for example, B is opposed to uh, beta, A is alpha and C is theta. Then the length of hypotenuse is square root of s squared plus b squared minus 2a times b times the cosine between them, which is theta. And sine law says a over sine of alpha is equal to b, length of b, divided by sine of beta and length of c over sine of theta. These are two important laws which is very useful in statics. By knowing that, we just create our parallelogram law. So if we just shift the F1 to this side and F2 to that side to create a parallelogram, and the red line between them is the resultant force, that's Fr. And because the X and Y axis make a 90 degrees. So that's 90 minus 15 minus 10, which made the between of them is 65. So the other one is 65. So then 360 minus 2 times 65, it just gives us the two other angle, which is 115 degrees at the sides here. And this is the resultant force. This is 65. This is 65 based off our calculation. So if that's the case, we have all the angles and dimensions. So as soon as we have that, we can just use half of the figure and use the cosine law. Fr is a square root of 100 plus 150 squared minus 2 times 100 times 150 times cosine of their between. So this is 100, this is 150, and their theta between them is 115, so that gives us F sub R is 212.6 newtons, almost 213 newtons. And law of sine says 150, 150, which is this one, over sine of theta is equal to Fr over sine of 150. The only unknown here is theta, so it just gives us a theta is equal to 39.8 in terms of degrees. So as soon as we have that, we can just calculate phi, which is the direction, the angle phi is the direction of Fr or resultant force measured from the horizontal axis or x-axis. So if that's the case, phi, we already calculated what theta is, and if we add that to 15 degrees from horizon to F2, which is 15, it just gives us phi is equal to 54.8. Thank you. We'll solve more problem in statics.